In this video, we're going to take a look at how we solve linear inequalities, as well as how we work with, it's called interval notation, because those go hand in hand together pretty significantly. So the first thing we want to note when we're working with inequalities is that linear inequalities have a range of answers rather than just a single answer. Up until now, we're used to seeing x equals a single number. X equals 5, x equals -3, x equals -5/3, something like that. We have just a single number answer. Well, now we're going to have answers where it's a range of answers. It's not one thing, it's a whole big long stretch of stuff. So we have four main types of inequalities that can kind of be broken down into two different groups. We have greater than and we have less than. These are instances where we are told something, let's say x, is greater than the number 3. So it has to be bigger than the number 3. That's kind of our checkpoint spot on a number line, but we want all numbers bigger than that. And then in contrast to that, we have the less than, which would be any number smaller than that, or lower in value than that. We then have the greater than or equal to, less than or equal to symbols. Notice that these two have a little extra line underneath the inequality. That's the part that denotes that we have the or equal to part with these answers. So if we had something to the effect of n is greater than or equal to 5, okay, that means that we can have any number that is 5 or bigger than 5. In contrast to that, if we have less than or equal to, let's say we have y is less than or equal to -3, then that means y is -3 or any value that's lower than that. Now I think that these four ideas and inequalities in general are best illustrated and best visualized using a number line, especially when we're working with less than and less than or equal to. A lot of people, understandably, but do make the mistake of thinking it's the smallest number, meaning the thing that's closest to 0 is always the thing that's less than. And it turns out that on a number line, less than is just always going more and more in the negative direction. And I think a number line helps visualize what that looks like. So we're going to go through and take a look at a couple examples on a number line and look at these examples in inequality or interval notation, which we're going to get to here shortly. But with a number line, we need to make sure that we are writing out and defining a few things. If we don't do this, then there's room for misinterpretation on number lines, and at the very least in my class, we're probably going to get wrong answers, and I'm not going to be grading what's been given to us, or what's been given to me to look at and grade. So we want to define where is 0 on our number line. That's generally a good starting place with these. We want to define then what's the positive and negative directions. Going to the right, is that going to be positive, or is going to the left going to be positive? You need to make that choice. We also want to define how we're scaling the axes. Is every single tick mark going to be going up by 1s or down by 1s? Am I going up by 3s, by 5s, by 10s, down by 3, 5s, and 10s? We want to make sure we have that defined for ourselves. And once we've done that, then we can actually go and graph the inequality that has been given to us. If we have the greater than and less than symbols, then that corresponds to using parentheses, meaning we have that number, but we are not going to include that number as part of our answer, meaning we are excluding that point. We also see this sometimes written with an open circle on a number line. In contrast to that, we have the greater than or equal to and less than or equal to symbols, which correspond to using brackets, which means we include that point. This can also be written sometimes using a closed circle on a number line. And I'll try showing both of these when we're working with our two examples that we have down here. The last part that I want to get to before we dive into these examples and see what it looks like is how we work with different types of notations. So we have two main types of notations when we're working with inequalities that work with them. And we're asked to use we're given one and asked to write it in the other one in our directions here. We have inequality notation, which is x is greater than something, x is less than or equal to something. It's using these four main symbols that we started with at the top. So anything that uses this inequality is referred to as inequality notation. Now the other one that we have, and this is a very significant, very common one that we see, it's called interval notation. What we do with interval notation is always list the lowest possible value, whether we include it or not, on the left side, and then we include the largest possible value, whether we could include it or not, in the right spot here. On either end of these numbers, we then fill those in with brackets or parentheses. Which one we use all depends on the inequality that has been given to us. Potentially, it could come from other information in a problem, but for what we're going to see, it's going to be coming from the inequalities that are presented. So come back and review these as necessary. I don't think there's anything wrong with looking at your notes as you're going through and rewriting these things. I think it's pretty much required as we're learning this. But we're going to go through and then rewrite things into this interval notation. Now, two main notes with this interval notation. One of them, this first one, I do have the red stars here for a reason. If you are writing any of these notes down for yourself, please put these red stars around this particular bullet point. This is a very, very important concept and requirement with interval notation that a lot of people don't follow. The order in which interval notation is written does matter. The lowest number always is written on the left, and the largest number is always written on the right. So you can have two negative numbers showing up in here, or two positive numbers, or a positive and a negative, or, as you see with these examples, negatives and positives, infinities showing up even. We still need to make sure we know which one is the lowest number between those two and which one is the largest number between those two. If you're ever unsure as to when you're comparing two numbers and trying to determine which one's larger, which one's lower, anything like that, here's an interesting kind of quick way you can think about it. Put a $sign in front of the two numbers or things that are written out and tell me which one would you rather have. Would you rather have negative infinite dollars, meaning you're in infinite debt, or would you rather have a positive $32? Well, you'd probably want to have the positive 32. That means this is your larger number, and we put it on the right-hand side. So this is just a small little silly way that we can keep track of these things, but I do want to make that note that interval notation order does matter. A lot of people think it doesn't. It absolutely does, and I have seen that burn way too many people on homework assignments and tests and things like that. So make sure you are writing the lowest thing first, largest thing second. Last but not least, before we dive into these examples, a positive infinity and a negative infinity will always have parentheses next to it. It doesn't matter which side of the inequality, the interval notation, I should say, we're working with, that is always going to have a parenthesis next to it. And the reason for that is because we are excluding the point infinity or the point negative infinity, because we can never actually reach either of those two numbers, because infinity and negative infinity aren't numbers. They're actually concepts. And we get to working with that in a lot more detail in much later classes. For all we need at this point in time is that negative infinity and positive infinity are numbers we can absolutely never reach, and therefore we use parentheses to exclude those. So let's jump into and take a look at our first two examples of graphing these two inequalities on number lines, and also get some practice with writing them out in interval notation. In our first example, we've been given the inequality x is greater than negative 2. So we have our basic framework of a number line written right down here. Now we need to determine which direction is positive, which direction is negative, and the spacing or the scaling, I should say, of this axis that we have here. Am I counting by ones? Am I counting by twos, by fives, by tens? Which one are we using there? So let's define, I think it's always useful to define which way is positive and negative first. So I'm just going to put a little positive here and a little negative here. So my positive and negative directions. Now I've been given x is greater than -2. So I don't really need to make these leaps from one tick mark to the next really big. So I could count by ones or twos. I think either of those would be acceptable. Whichever one I am choosing, I do want to stay consistent with that. So I'm going to go ahead and count by ones here. And label that on this side. So in this case, you're seeing that I'm counting 1, 2, 3, 4, 5, 6, 7. Every single thing is marked. You could probably also write this out going every other tick mark as long as you stay consistent. So you could also go -1, -2, -3, -4, -5, -6, something like this. Either of these in my class would be perfectly acceptable for how you're spacing or scaling these things out and writing that out on a number line. Perfectly happy with these. So let's actually graph this thing. I'm going to show two ways you can graph this. Either one is perfectly acceptable. It depends on the program you're also using, if there's an online program or something like that. One or both of these may or may not be available, so just keep that in mind as you're going through and graphing these inequalities. So we're told that x is greater than -2. So I always find that the number that's been given to us, that's your starting point. So in this case, -2 right down here. Now I need to determine, am I going to use a bracket or a parenthesis with this thing? And with the greater than symbols, we're using a parenthesis. And I want everything that is greater than that. So all of the numbers to the right here in the positive direction are all greater than this. So I can put a parenthesis right at -2, and then everything after this fills in. Oops, make that a little bit better here. Fills in as potential numbers. So everything to the right of -2 works. The other option that you can use, instead of using parentheses, is to use the open or closed circle right at -2. Remember that the greater than symbol corresponds with an open circle, so instead of having a parenthesis here, I could put an open circle and then fill in everything to the right of that. Now this part that I have written up here, it's written above the number line. You could just put this down below and have it right on the number line if that's what the program or your instructor is calling for. But either way of writing these things out works. So we have this thing graphed. Fantastic. Let's rewrite this thing into interval notation. So that means we need to determine what is the lowest possible number that I have in this range of answers. We're not going to determine if we include it or not just yet, but we're just trying to find the lowest thing. So the lowest number looks like it would be -2 here. I'm going to write in a -2. That's my lowest number. What's the largest number? Well, this arrow on the end here implies that this number line in this graph is going to go on forever in this direction. So what's the largest thing it could possibly reach? Well, that's going to be a positive infinity. So I have my lowest value, -2, largest value, infinity. Now we determine, am I putting brackets or parentheses by the -2, brackets or parentheses by the infinity? For -2, we're looking at the inequality symbol that's been given to us. It's a greater than, and greater than always corresponds with parentheses. So this -2 is going to have a parenthesis around it. The infinity, whether it's a positive or a negative, whether the inequality is greater than or equal to, it does not matter. Infinity always has parentheses around it, no exception to that. And from here, we have the inequality, x is greater than -2, written out on a number line we have here, and written in interval notation like we have here. In our second example with graphing and rewriting this thing, we've been given the inequality x is less than or equal to 5. So again, we have our number lines set up here, we need to determine which direction is positive, which direction is negative, and scale this thing. So I'm going to once again define the positive direction going to the right, negative direction going to the left. 5 isn't too big of a number, so I'm going to go ahead and label these things going by ones each time. And I count as every other one, I should say, just to save a little bit of writing. And there we go. I have my number line, I have 0, I have the positive direction, negative direction. Great, I know where everything is. We've been told that x is less than or equal to 5. So I need to find where 5 is on my number line, right over here. And I'm getting in using all x values and all values that are less than or equal to that. So that tells me the or equal to that I'm going to have a bracket. And not only that, I'm going to have a bracket facing to the left. I'm going to have everything that is smaller than positive 5. So it's everything to the left here. Now, I'm using a bracket in this instance, but like the previous problem, maybe you're using an open or a closed circle. Remember that if we are working with a less than or equal to, then we are going to have a closed circle showing up. That tells me I can include 5 as a potential answer. 5 is, after all, less than or equal to 5, so that would work. And again, similarly, we'd have the closed circle there, and then I'm going to use all the numbers to the left of that that are lower than 5 on my number line. And there we have that thing graphed. Now, if we're going to rewrite this as interval notation, we once again need to determine what is the lowest possible value in this range of numbers and what is the largest possible value in this range of numbers. We'll figure out the bracket or parenthesis afterwards. So the lowest possible value, well, we've got, looks like we have arrows pointing down in the negative direction, which means this thing is going to go on all the way to negative infinity. There's a very big difference between this thing going to negative infinity and positive infinity. If you don't think that there's much of a difference, or you're not entirely sure on where that difference comes in, then let me ask the quick question of this. Would you rather have negative infinite dollars, or would you rather have positive infinite dollars? Which one? And hopefully we're choosing this positive one so we have infinite money, versus we never have any money of any kind, we're always in debt. So keep that in mind as you're writing these things out. Is it positive? Is it negative? Well, which way is it face? Is the arrow facing? And make sure we do include that in there. So that's our lowest value. What's the largest thing that we could possibly get to? It looks like that's going to be 5 here. So we'll write that in. Now bracket or parenthesis around the negative infinity. Well, remember, infinity, positive or negative, always has parentheses next to it. So we're writing that in there. For the 5, is it going to have a bracket or is it going to have a parenthesis? If we're unsure, we go back to the inequality. We've been told this x value is less than or equal to 5. So this less than or equal tells me that I'm going to have a bracket, which means I can include 5 as a possible answer. We can also reference the graph that we have written out if that would be helpful. But either way, we should be getting to the conclusion of having a bracket right next to the 5. And here's how we graph and rewrite the inequality x is less than or equal to positive 5. The second part of working with inequalities in interval notation is having us actually go through and solve inequalities algebraically. Thankfully, we're not really going to be changing much of anything that we do. All of our previously learned rules and methods and possibilities for solving linear equations, which was the 2.1 all the way up through the 2.6 material, all still apply the exact same way here. We still add, subtract, multiply, divide to both sides the exact same way. We can still eliminate fractions on both sides of an inequality the exact same way. We can still rewrite decimals or work with decimals the exact same way. All of our tricks and everything that we learned as well are still fair game too. So all of that we can still apply here. The only difference that shows up, and if you are taking notes on this and writing any of it down, these two parts here are the main things that you want to have written down, because this is where our main differences show up. If we multiply or divide both sides of an inequality by a negative value, then the inequality in the middle must change directions. It should be noted with this, this does not mean that a greater than becomes a less than or equal to, or a less than or equal to therefore becomes a greater than. Remember back to our different types that we had here. We have 4 types of inequalities. If something starts off as one of these two, it cannot change to one of these two down here. It's going to start in this category, or it's going to start in this category, and it's just going to switch between these two or switch between those two there. These do not switch from one type to another type in that regard. So all that happens when we multiply or divide by a negative is the inequality changes directions. When we go through our first example, I'll highlight why this is once, and just be aware that that's the case, and that's the reasoning for all of our other methods or other problems that we go through as well. You're welcome to write it out in that regard and use that if you'd like to, but I just want to make sure that you can see where and why that is the case. Last but not least, make sure that you are writing the final answer the way that the problem is asking you to. Sometimes problems are okay with you writing things in inequality notation, like we have right up here, the greater than, less than, greater than or equal to, something like that. Or maybe you need to write it in interval notation, like we saw with some of our other examples previously. Make sure you are reading the question and giving your answer in the form that it is asking for. So we're going to take a look at these 4 examples down here, noting that all of our previously learned material from 2.1 to 2.3 is eligible to be showing up on here as well. So that includes having a single number answer, having infinite answers, and having no answers showing up as well. So we'll take a look at what that does or doesn't look like with these 4 examples here. Taking a look at our first example, we have negative 4x plus 1 is greater than 13. We are told to solve this thing for x. Alright, so my goal is to get x all by itself on one side of the inequality sign. Again, doesn't matter which side, I just want it all by itself. So, I can go through and I can solve this thing the exact same way I would any problem from the 2.1 to 2.5, 2.6 material. So trying to get x all by itself, I'm going to go through using the method that we learned in the 2.1 to 2.3 material, and I'm going to get rid of all other constant terms on this left side to get the variable terms all by themselves. So I'm subtracting 1 on both sides. So I have negative 4x remaining. That's going to remain greater than 12 here. I subtracted. I did not multiply or divide by a negative, so the inequality stays facing the same way. Now with my next step, I want to get this x all by itself. I want to get rid of the 4 and the negative in front of this because this is negative 4 times x. So I'm going to divide both sides by negative 4. And this is where, in my next line, this inequality needs to change direction. In fact, I would almost recommend we do that first. I'm dividing by a negative, inequality has to change. Okay, great. Now I work with the numbers and variables as I would normally. Negative 4 divided by negative 4, that's just going to give me a single 1x left over. 12 divided by negative 4, that's going to give me a negative 3. Positive divided by a negative is a negative. Now I've been told I need to write my final answer in interval notation. So I need to determine, is this negative 3 my lowest possible value or my largest possible value? Meaning, is it going to go on the left side of the interval notation or the right side? And we're told is that x is less than negative 3, which means that this negative 3 has to be the largest value that we have. Which means if it's the largest value, the lowest value would have to be negative infinity. Any and everything lower than negative 3 in value. Okay? Brackets or parentheses, infinity and negative infinity always have parentheses, so we're good there. Negative 3, well, I need to take a look at this inequality. It's less than, and the less than or greater than inequalities always have parentheses around them also. So in this case, we have parentheses negative infinity to negative 3 with parentheses around that as my final answer for example 1. Now I do also want to go through and just once show why it's the case that we need to flip this inequality. I'm not going to do this in the future examples, but I just want to see where this comes into play here. So let's say we're starting at this part again. And maybe you're someone who's in the boat of saying, I don't want to have to worry about when and if I need to flip this inequality back and forth or anything like that. I don't like dividing or multiplying by negatives because I don't like flipping, so I'm going to get rid of this in a different way. I am going to add 4x to both sides of this inequality. We can absolutely do this. We're going to see that it takes a few extra lines to get to our answer, but it is something that we can do with these problems. And now I'm going to subtract 12 from both sides because I want to get the 4x all by itself. So I have negative 12 is greater than or equal to 4x. Now, when I divide by 4 on both sides, I don't need to worry about flipping the inequality at all when I'm doing division. I'm going to get negative 3 is greater than x. Now, the last thing that you can do, I think it's very helpful to rewrite inequalities that are in inequality notation anyway, always having the variable on the left side. So I'm going to basically flip this entire expression. I'm putting the x over here. I'm putting the negative 3 over here. Now I want to determine and remember which way was this inequality facing. It was opening up to the negative 3. So that means in this next line, the inequality better be opening up to the negative 3 yet again. And what we notice now is that between these two things here, we have the exact same expression. We have x is less than negative 3, x is less than negative 3. And then we would rewrite both of them into this interval notation that we have right here. So this is why we end up having to flip this inequality when we divide or multiply by a negative number. It's because if we were to get rid of this negative sign using addition and subtraction, we are effectively flipping the inequality at some point in time in that problem. So if we do it with multiplication or division, it saves us some extra steps, certainly, but it does mean that we need to flip the inequality to go along with that. So just wanted to note that and show that at least once with our first example. Moving on to our second example, we're not going to see this as much, but I just want to make sure you're aware that this is going on in the background of all of these problems if we multiply or divide by a negative number. Our second example of solving inequalities algebraically is given to us here. Now we have a whole bunch of fractions that are showing up with this particular problem. We have 1/2 x plus 5/8 is less than or equal to 3/8 x minus 4 or 11/4, I should say. So, yay fractions. Well, thankfully, we learned a process previously of how we go through and we eliminate fractions in equations, and we can therefore use that again in working with inequalities. So we need to determine what is the lowest common denominator between all of the fractions that show up in this particular problem. So between 2, 8, 8, and 4, what's the lowest common multiple between all of them? Meaning, what is the smallest number that 2, 8, and 4 can all multiply into? And that number is going to be 8. 2 goes into 8, 8 can multiply into 8, and 4 can multiply into 8. Now remember, the reason we are doing this is because we want to eliminate fractions. We don't want to work with them. They can be a bit more of a pain than necessary. So let's get rid of those first before we actually go through and solve the rest of this thing. So once I have this lowest common denominator determined, every single thing, whether it does or does not contain a fraction, is going to get multiplied. Whoops, it should be by 8. Let me actually write in the right number here. Everything is going to get multiplied by this lowest common denominator, which is 8. Remember, if it has a fraction, great. If it doesn't have a fraction, great. It's all still multiplying by 8. Now at this first part, I have an 8 in the numerator spot, 2 in the denominator. So that means these things are going to cancel. The 8 becomes a 4, 2 becomes a 1. And I end up getting 4 times 1, which gives me 4x. I have 5 over 8 times 8. I have an 8 in the numerator, 8 in the denominator. These things each cancel out to become 1, which means I'm going to have just 5 left over here. While I am multiplying to both sides, I am not multiplying by a negative, so this inequality comes down exactly as it was. I now have 8 times 3 8s. The 8s cancel out. They each become 1s, and I get 3x left over. And then in this last part, I have an 8 in the numerator spot, a 4 in the denominator. Well, those are going to cancel. The 4 becomes a 1, the 8 becomes a 2. And I have 11 times 2, that's going to give me 22 at the end. And suddenly, now, all my fractions are gone. I haven't actually solved anything, but this is going to be some much nicer numbers to work with. Now from here, if you remember back to the process that we learned in the 2.1 through 2.3 material, I gave the hint of always eliminating the variable term that has the lowest valued coefficient in front of it. The reason for that is because if we do that, especially in these inequality problems, we will absolutely never have to multiply or divide by a negative at the very end of the problem, meaning we won't ever have to worry about flipping this inequality. Now, if you're someone who says, I'm always going to get rid of the bigger value or always the something on one side of the inequality, you're welcome to do that. There's nothing wrong with it. As you saw with the first example, there's nothing wrong with multiplying or dividing by a negative in these problems. It just means you have one extra thing you need to keep track of at the very end is all. But this little trick, all the way back from the 2.1 through 2.3 material, is going to come in pretty handy here because it's going to take out a lot of potential headache for us, where we need to worry about flipping the inequality at all. So I now have x plus 5 is less than or equal to negative 22. I'm subtracting 5 from both sides, and that gives me x is less than or equal to negative 27. Okay, I now need to get this thing into interval notation. Is this negative 27 the largest possible value or the lowest possible value? It's going to end up being the largest. We're told x is less than or equal to negative 27. So that means it's going to be the large value here. And if that is the large value, then x is going to go and get smaller and lower in value on and on and on and on, which means that this lowest value is going to have to be negative infinity. Now, negative infinity always has parentheses next to it. The negative 27, bracket or parenthesis. We look at the inequality that's been given to us. It's less than or equal to, which means that this thing is going to have a bracket showing up around it. That gives us our final answer in interval notation of negative infinity, comma, 27, or negative 27, I should say. For example 3, we have some other kinds of prep work that we need to do to go through and set up and simplify this inequality down. So we are given 5 times the quantity x minus 4 is less than 3 times the quantity x plus 1, all subtracted by 8. So again, using our process that we learned in the 2.1 and 2.3 through 2.3 material, I should say, we're simplifying each side of the inequality individually. So this 5 is going to distribute through to everything on the left side here. So I'm going to end up getting 5x minus 20. I can't combine anything else together on that left side, so that's fine. We have 5x minus 20, and we'll just leave it there. On the right side, we have this 3 times the quantity x plus 1. That's going to give us 3x plus 3. And then the minus 8 is still just sitting there from our first step to our second. I'm looking to see, can I simplify this any further? Meaning, can I condense anything down and combine any like terms? Yes, I can. I can put this negative 3 in the, or I should say positive 3, and the negative 8 together. That's going to give me 3x minus 5. I haven't changed anything else in this problem, so I'm just bringing everything else down exactly as it is. And now I have 5x minus 20 is less than 3x minus 5. Fantastic. We're just going to go through and solve this thing like we did in previous problems. I'm going to get rid of the lower valued variable term, this negative, this 3x here. So I'm going to subtract 3x from both sides. I'm left with 2x minus 20 is less than negative 5. I'm going to end up adding 20 to both sides to get the 2x all by itself. And that gives me 2x is less than positive 15. And then last but not least, I need to divide both sides by 2. I'm getting x. I'm going to move this or rewrite this over here off to the side just so I have some space. That's going to give me x is less than 15 over 2. So fantastic. I've got a fraction answer, but you know what? We're fine with fractions at the very end of a problem if it's just the final answer that we've been given. Now, rewriting this thing into interval notation, this 15 over 2, is this going to be my largest value or is this going to be my lowest value? Well, we're told x is less than 15 over 2, so that means that this 15 over 2 is going to be our largest possible value, which means our lowest possible value is going to be negative infinity. Negative infinity always has parentheses going on around that. This 15 over 2, well, that's going to also have parentheses, and I use the inequality in the center to determine that. We're told that this x is less than 15 over 2, so that means we're going to use the parentheses with that. And that gets us to our final answer here for example 3. And this brings us to our fourth and final example that we have for solving inequalities algebraically. We're given 8m minus 2 times the quantity 4 minus m is greater than or equal to 7 times the quantity m minus 4, and it has plus 3m added to that at the very end. So again, like I've done with my previous problems, I'm going to go through and I am going to simplify each side of this inequality before I start adding, subtracting, multiplying, and dividing to both sides. So the 2 is going to multiply through on the left side. And I'm going to get 8m minus 28. There we go. Plus 2m. Bringing the inequality down just to keep that consistent. I'm combining like terms on this left side here, and I'm getting 10m minus 28. I can't combine anything else together. That's fine. Bringing the inequality down, and we're just going to leave it exactly as it is there. On the opposite side of the inequality, I'm going to just simplify things down. This 7 is going to multiply through to everything inside the parentheses. We get 7m minus 28, and then plus 3m at the very end here. So I have 7m and I have 3m. These two things can combine together. We're going to get 10m minus 28. And now right here at this stage, hopefully we're seeing and noticing something about both sides of this inequality. These two things are the exact same as one another. They are identical. If we remember back to the 2.4 material where we have identical things on both sides of an equation, that means we are going to have infinite answers showing up. The same thing is going to apply here, even though we have inequalities. What m values will make this side of the equation, or the inequality, greater than or equal to this right side of the inequality? Well, that's going to be all real numbers. A lot of people like to write out negative infinity all the way up to positive infinity. And while that's technically not incorrect, we do want to more accurately, more specifically write this out instead as using the symbol for all real numbers. It's this little double R that shows up here. That represents every single real number that we could think of. Positive, negative, fraction, decimal, all of it. And this would be our final answer for this particular problem. Now, the one thing that I do want to highlight as well is the possibility of maybe we get to the same place, but we have something slightly different here. So I have this step start. I'm going to rewrite it with one slight variation. So let's say we have 10m minus 28. Oops, let me make that 8 a little bit better. Greater than 10m minus 28. Now we are being asked, where is this left side of the inequality greater than the right side of this inequality? Well, if we're looking at these things, they're identical, which means it doesn't matter what value of m I plug into both sides of this inequality, they are going to be the exact same thing. So can something be greater than something identical to it? No, it can't. It's going to be equal to it in every single instance. So if we have kind of a weird situation like this showing up, this is where we would end up saying that there is no solution. It could be the case that maybe you're supposed to write in DNE for does not exist. It'll depend on the problem and your instructor with which one they'll be looking for and expecting you to write in. For the purposes of my class, write in no solution as the final answer. And if you're in someone else's class or using a different online program, I would check with them to make sure what specific form they want you to write your final answer in. But just want to know that this is a possibility that can show up as we are going through and solving these things with inequalities. So as a quick recap of the material that we learned with solving linear inequalities in interval notation, we had 4 types of inequalities that we covered, and they span 2 types of groups, as you could call them: greater than, less than, greater than or equal to, less than or equal to. We went through how to set up and work with these things on number lines, making sure that we are clearly defining 0, the positive, negative directions, and then scaling the axes. And then we have instances where we are using, noting when we use parentheses and when we use brackets, depending on the inequality form that's been given to us. Going along with those, we could use open or closed circles similarly in the graphing process. We had our first 2 examples regarding writing things out on those number lines and writing them in interval notation. Remember, between our 2 types of notations, we have inequality, where we actually see greater than, less than, greater than or equal to, less than or equal to showing up. And then we have interval notation. Remember, with interval notation, the order that you write things out in absolutely does matter. It is always the lowest number on the left, always the biggest or the largest number on the right. Then we went through and worked with solving these things algebraically. All of our previously learned methods, which is the 2.1 through 2.6 material, all of that is still fair game here. All of our tips, all of our tricks that we learned and we covered, you can still use those here when solving inequalities. Just as a last reminder, make sure that when you multiply or divide both sides of an inequality by a negative value, that's the only time when the inequality must change directions. Beyond that, it stays facing the exact same way as it does. We had our 4 examples that we went through here. We kind of saw 4.5 examples just because of the other possibility of no solution showing up with our 4th example here. So we also have a couple extra problems that we can try working on for ourselves if you'd like to. I'd recommend pausing the video, writing these out, and trying some of them for yourself. Make sure you're reading the directions and answering it in the form that you are being asked to. Now let's scroll on down and let's get our final answers for each of these things as well. Hopefully, as we were going through, we were noting that, we have all real numbers and potentially no solution showing up with some of these problems. That is a pretty standard issue thing that shows up with them, so just be on the lookout for that as you're going through these problems. But otherwise, that will do it for inequalities and interval notation.